Did you know that elements is like people and have different personalities? A few elements are very shy and like to be left alone. Others are extremely social and prefer to hang out with friends. Helium and neon are some elements that prefer to be alone. However, most elements like hydrogen and oxygen are social and prefer to hang out together and build molecules and compounds. Each compound have their own properties.
Hi class, so today I would like to introduce to you the properties of covalent compound and ionic compound. Let's go! Do you remember what is covalent compound? Covalent compound results from two nonmetals atoms that reacts with each other. The bond is formed by equal sharing of electron from both participating atoms in order to achieve stable doublet or stable octet electron arrangement. Oh, I know what is covalent compound now. What about ionic compound? Ionic compounds usually related to transferring of electron between metal atom and non-metal atom. Ionic compound results either positively charged ion, which is cation, where metal atom donates the valence electron, while negatively charged ion called anion is non-metal that receive electron from metal atom. Teacher, can I know what is the example of ionic compound and also covalent compound? Good question. So the example of covalent compound is water, H2O, chlorine gas, Cl2, and also carbon dioxide, CO2. Do you know that water, H2O, is the combination of hydrogen and oxygen that share a pair of electrons to make a molecule of two hydrogen bonds single bonded to single oxygen. What about the example of ionic compound? Example of ionic compound is sodium chloride and NaCl, which also called as table salt. Other than that is sodium bicarbonate, baking soda, and sodium fluoride, which is your toothpaste that you usually use in your toilet. So now, we will move on to the properties of covalent compound and ionic compound. The properties of both compound are melting point and boiling point, solubility, water and organic solvent, and also conductivity of electricity. Properties of ionic compound is high melting point and boiling point. Why? It is because positive ions and negative ions in ionic compounds attracted to each other by strong electrostatic attraction force. High heat energy is required to overcome the attraction force. The other properties of ionic compound is it is soluble in water, but it is insoluble in organic solvent. Do you know what is the difference of water and organic solvent? Organic solvent is a carbon-based substances that capable of dissolving, of dispersing one or more other substances, while water is an inorganic substance that do not contain carbon. A lattice structure of solid ionic compound collapses when dissolved in water because water molecules helps to overcome electrostatic attraction force between ions, while this process does not occur in organic solvent. Lastly, the properties of ionic compound is it can conduct electricity in a molten state and aqueous solution. In solid state, oppositely charged ions are bonded with strong electrostatic attraction force. Thus, ions cannot move freely, while in molten state or aqueous solution, ions can move freely and can carry charges to conduct electricity. The properties of covalent compound is low melting point and boiling point. The molecules of covalent compounds are attracted by the van der Waals force. It requires low heat energy to overcome the attraction force. Other than that, covalent compound is soluble in organic solvent, but it is insoluble in water, H2O. Molecules of covalent compounds are soluble in organic solvents because they are neutral and they do not carry any charges. Lastly, covalent compounds do not conduct electricity at all states because it consists of neutral molecules where there are no free-moving ions that carry charges.
Now, it is the time for us to look at the example of experiments.
We're going to take a look at conductivity of certain compounds. So ionic versus covalent compounds, one of them likes to conduct electricity, the other one not so much. And here's what I mean by conducting electricity. Electrons like to flow through certain materials. So the electrons will actually bounce from one atom to the next, and that's what electricity basically is. So what I made was a little conductometer 3000, patent pending on that one. So what it is really is just a circuit. So I have a battery pack hooked up to this little propeller. If I close the circuit, the propeller will spin. It's showing that the electricity is in fact conducting through the wires, making the motor spin and continuing the circuit, okay? We could just test some random objects, screwdriver. We'll take a look at the metal part of the screwdriver. And you'll notice I'm not going to touch these. I'll just kind of put them on the screwdriver and it will make the propeller spin because the electricity is in fact running through the screwdriver. If I try it on the handle of the screwdriver, which is plastic, no conduction there, all right? Key in my car. Again, the metal part is going to conduct, the plastic part, not so much. Hole puncher, make a prediction in your head right now. What do you think is going to happen with the hole puncher? Conducts. Pen, let's try the tape. We already did plastic. Tape, not so much, okay? So again, our different types of compounds, one will conduct, one will not. Let's test them out. So I'm going to put one end of the probe into the water. Now normally, guys, disclaimer here, you are not going to introduce electricity to any liquids ever, okay? This is an extremely low current. I could even touch them, nothing's going to happen because I'm only working off a AA battery here, okay? So there's not a whole lot of danger here. But normally, you're never going to try something like this at home. So let's try the sugar water first. I'm going to put one probe in on one side of the beaker and the other probe in the other. I'm going to see if the electricity will actually run through the liquid and meet the other probe. And you'll know if the propeller spins. And I got nothing. All right, quick dry. And let's try the salt water. Again, I want you to notice the probes are not touching in the solution. The electrons are flowing through the solution to close the circuit, going through the water to close my circuit. So that is in fact conducting electricity. Alright guys, next up we're going to take a look at, again, an ionic and a covalent bond, a compound, to see which one will melt quicker. So I have just plain old salt and just plain old sugar. I measured out exactly 1 gram of each on my balance over here, and we want to see how long it takes for each of them to melt. So what we're going to have here is little homemade frying pans here for you. Soak them in water so they don't light on fire. Just going to pinch one on the end here, starting with sugar. This one is sugar. Light my tea candle. Start my timer as I lower it down onto the flame. All right, so as you can see, my sugar is starting to melt at about 45 seconds. It began to melt. I'm not going to keep melting it because it's going to start to burn and smoke, and I don't want to set off the fire alarms. So we're going to stop it at 45 seconds because that's when it just started to melt. And we're going to put under sugar 45 seconds. All right, moving on to salt. Set my timer. Put it on there, light my tea light. All right, And start. All right, so I've been waiting here about 5 or so minutes, and spoiler alert, this is not going to melt. We need 1,474 degrees Fahrenheit to melt salt. We are not going to get anywhere near that with our little tea light.
For a conclusion, today we have learned about what is the definition of ionic compound and covalent compound, and also the properties of each compounds. I hope the video of experiments have helped you to understand more about the properties of each compounds. That's all from me. Thank you for watching.